Today I talk about very most important topic, alternating current. Okay, this topic is very most important. Okay, please you follow line by line. I thoroughly reading and explaining. So first you understand alternating current. What is mean by alternating current? Write an write an experience for it. Define its amplitude, time period, and frequency. So first you understand alternating current. An alternating current is that current whose magnitude changes continuously with time and directions reverse periodically. In contrast to it, a direct current is that current which flows with a constant magnitude in the same directions. You understand this diagram, it is alternating current and it is direct current. Next we know how that when a coil is rotated in a magnetic field, an alternating EMF is induced in it, which is given by the relations E is equal to E naught sin omega t. Suppose this EMF is applied to a circuit of resistance R, then by Ohm's law V is equal to IR. Okay, and the current is the circuit will be I is equal to E by R. So E naught by R sine omega t. I is equal to I naught sine omega t. Thus the current is the circuit varies varies sinuously with time and is called alternating current. Here I is equal to instantaneous value of AC at any instant t. I naught is equal to E naught by R is equal to peak or maximum value of AC and is called current amplitude. Amplitude, the maximum value alternated by an alternating current is either direction is called its amplitude or peak value and is denoted by I naught. Time period, the time taken by an alternating current to complete one cycle of its variations is called its time period and is denoted by t. This time is equal to the time taken by the coil to complete one rotational in the magnetic field, as angular velocity of the coil is omega and its angular displacement is 1, completely circle is 2 pi. So time period is equal to angular displacement in a complete circle by angular velocity. So t is equal to 2 pi by omega. Frequency, the number of cycle completed per sound per an by an alternating current is called its frequency and is denoted by f. The frequency of an alternating current is same as the frequency of the rotations of the coil and the coil in the magnetic field. Thus f is equal to 1 by t is equal to omega by 2 pi. So the alternating current can be represented as I is equal to I naught sine omega t is equal to I naught sine 2 pi ft is equal to I naught sine 2 pi by t into t. Those the variations of alternating current with time. Its rises from 0 to maximums is one directions, the falls to 0 and the rises from 0 to maximums in the opposite directions and again falls to 0, thus completing the full circle. The alternating current supplied to our houses and has a frequency of 15 cps or 15 Hz, as the alternating current is positive in one half circle and equally negative in the other half circle, so its mean value over a complete cycle is 0. We can prove it's mathematically also prove mathematically that the average value of alternating current over one complete circle is 0. Average value of alternating current over one complete cycle, the alternating current at any instant t is given by I is equal to 100 sin omega t. Assuming the current remains constant for a small time dt, then the amount of charge that flows through the circuit is small time dt with will be dq is equal to I dt is equal to I naught sin omega t into dt. The total charge that flows through the circuit in one complete circle of AC. Q is equal to integration of dq is equal to close in dq. Q is equal to integration dq is equal to integration 0 to t I naught sin omega t dt is equal to I naught minus cos omega t by omega 0 to t is equal to minus I naught by 2 pi by t into cos 2 pi by t small t 0 to t is equal to minus I naught t by 2 pi. Cos 2 pi minus cos 0 is equal to minus I naught t by 2 pi into 1 minus 1 is equal to 0. The average value of AC over one complete circle of AC, I average is equal to Q by T is equal to 0. Thus, the average value of AC over a complete cycle is AC is 0. Okay. Next topic, ordinary moving coil galvanometers used for DC cannot be used to measure an alternating current even if its frequency is low. Explaining why. Okay. Next, I discuss about ordinary moving coil galvanometer cannot be used to measure AC. Ordinary moving coil galvanometers is based on magnetic effect of current, which in turn depends on directions of current, so it cannot be used to measure AC. During one half cycle of AC, its pointer moves in one direction, and during next half cycle is it will moved in the opposite directions. Now the average value of AC over a complete circle is 0. Even if we measure an alternating current of low frequency, the point will appears to be stationary at the 0 positions due to percentage of vision. We can measure AC by using a hot right ammeter, which is based on heating effect of current, and this effect is independent of the directions of current. The measure AC, we define the mean value of AC over half a cycle or its root means square value. Mean or average value of AC. Define average value of AC over half a cycle. Stabilize the relationship between the average value and the peak value of an alternating current. Average value of AC, it is defined as the value of direct current which sends the same charge in a circuit in the same times as is sent by the given alternating current in its half time period. It is denoted by I average or IM. Relations between average value and peak value of AC. The value of alternating current at any instant t is given by I is equal to I naught sin omega t. This current can be assumed to remain constant for a small time dt. That the amount of charge that follows through the circuit in small times dt is given by dq is equal to I dt is equal to I naught sin omega t dt. The total charge that follows through the circuit, say in the first half circle, if from t is equal to 0 t is equal to t by 2 is given by q is equal to 0 to t by 2, dq is equal to 0 to t by 2 I naught sin omega t dt is equal to I naught minus cos omega t by omega 0 to t by 2 is equal to I naught is equal to minus I naught by 2 pi by t cos 2 pi by t into t 0 to t by 2 is equal to minus I naught t by 2 pi cos pi minus cos 0. Next omega is equal to 2 pi by t. Next minus I naught t by 2 pi into minus 1 is equal to I naught t by pi. Okay. The average value of AC over the first half cycle is I average is equal to charge by time is equal to Q by T by 2 is equal to 2Q by T is equal to 2 by T into I naught T by pi. I average is equal to 2 by pi I naught is equal to 0.637 I naught. Okay, I average is equal to 2 by pi I naught is equal to 0.637 I naught. I average is equal to, always remember this topic, and omega is equal to 2 by t. This equation is very most important. Next I talk about thus the means or average value of an alternating current is T 2 by pi or 0.637 times its peak value. The similar relations can be proved from the alternating current, which is E average is equal to 2 by pi epsilon naught is equal to 0.637 epsilon naught. Roots mean square RMS or virtual or effective value of AC. What is meant by RMS value or effective value of an alternating current? Derived a relation between it and its peak value. Okay. Next I talk about root mean square or roots mean square or virtual or effective value of AC. It is defined as the value of a direct current which products the same heating effect in a given resistors as in product by the given alternating currents when passed for the same time. It is denoted by I, RMS, IV or by IEF, IEFF. Relation between the effective and peak value of AC. Suppose an alternating current I is equal to I naught sin omega t be passed through a circuit of resistance R. Then the amount of heat produced in small time dt will be dH is equal to I square R dt. If t is the time period of AC, then heat produced in on complete circle will be H is equal to 0 to T I square R dt. Let IEFF be the effective value of AC, then heat product in time T must be H is equal to I square EFF RT. I square EFF RT is equal to 0 to T I square R dt. I square EFF is equal to 1 by T 0 to T I square dt. But 1 by T 0 to T I square dt is the mean of the square of the instantaneous value of AC over one complete circle. Hence, the effective or virtual value of AC equal its roots mean square value IEFF is equal to IRMS is equal to root over 1 by T in integration 0 to 2 I square dt. Now 0 to 2 I square dt is equal to 0 to 2 I naught square sin square omega t dt is equal to 0 to 0 I naught square 0 to 2 1 minus cos 1 minus cos 2 omega t by 2 dt is equal to I naught square by 2 into t minus sin 2 omega t by 2 omega 0 to 2 0 to t is equal to I naught square by 2 into t minus 0 minus 1 by 2 omega sin 2 pi by t into t 0 to t. Next, I naught square by 2 into t minus 1 by 2 omega sin 4 pi minus sin 0. I naught square by 2 t minus 0 is equal to I naught square t by 2. Therefore, IEFF or IRMS is equal to root over 1 by t into I naught square t by 2. IFF or IRMS 1 by root 2 I naught is equal to 0.707 I naught. Thus, the effective or RMS value of an AC in 1 by root 2 times its peak value. Next topic, root mean square value of an alternating EMF. Define the root mean square value of an alternating EMF. Derive a relation between it and its peak value. Roots mean square value of an alternating EMF. It is defined as that value of a steady voltage that produce the same amount of heat in a given resistance as is produced by the given alternating EMF when applied to the same resistance for the same time. It is also called particular or effective value of the alternating EMF. It is denoted by E RMS or EFF or EV. Relation between the RMS value and the peak value of an alternating EMF. Suppose an alternating EMF E applied to a resistance R is given by E is equal to E naught sin omega t. Heat produced in a small time dt will be dH is equal to E square by R, dt is equal to E naught square by R sin square omega t dt. Let t be the time period of the alternating EMF, then heat produced in time t will be H is equal to integration dH is equal to 0 to t E naught square by R sin square omega t dt is equal to E naught square by R 0 to t 1 minus cos 2 omega by 2 dt is equal to E naught square by 2R t minus sin omega t by 2 omega 0 to t is equal to E naught square by 2R t minus 0 minus 1 by 2 omega sin 4 pi by t into t 0 to capital T. Next, E naught square by 2R t minus 1 by 2 omega sin 2 pi minus sin 0 h is equal to E naught square by 2R t minus 0 is equal to E naught square t by 2R. If ERMS is the root mean square value of the alternating EMF, then the amount of heat produced by it in the same resistance R in the time t will be H is equal to E square RMS t by capital R. Okay. Next, for the above two equal, we get E square RMS t by R is equal to E naught square t by 2R. E naught E RMS is equal to E naught by root 2 is equal to 0.707 E naught. The alternating current and voltage are generally measured and specified in terms of their RMS value. When we say that the household supply is 220 volt alternating current, we mean that its RMS value is 220 volt. The peak value would be V naught is equal to root 2. Vrms is equal to root 2 into 220 is equal to 311 volt. Both alternating and direct current are measured in amperes. However, it is not possible to define AC amperes in terms of force between two parallel wires carrying AC current. As the DC amperes is defined, this is because the alternating current change directions with the source frequency, and so the net force would add up to zero. To overcome this problem, we define AC amperes in terms of joules heating H is equal to I square RT, which is independent of the directions of current. Hence, the RMS value of alternating current is a circuit is 1 amperes of the current and produce the same average heating effect as 1 amperes of direct current would produce under the same conditions. Alternating current and voltage are measured by AC ammeter and AC voltage respectively, as the working of these instrument is based on the heating effect of current, so they are called hot wire instrument. Next, I talk about example based on some important formula. First, means effective instantaneous value of alternating current and voltage. Instantaneous value of AC I is equal to I naught sin omega t where I naught is the peak of maximum value of AC, average or mean value of AC over half cycle. I average is equal to 2 by pi I naught is equal to 0.637 I naught. Effective or RMS or virtual value of AC is equal to IEFF or IRMS or IV is equal to 1 by root 2 I naught is equal to 0.707 I naught. For alternating voltage, we have E is equal to E naught sin omega t. E average is equal to 0.637 E naught. E RMS is equal to 1 by root 2 E naught. Units of use: current I naught, I RMS are in amperes, voltage E naught and E RMS are in voltage. Okay, all topic is very most important. Please you revision this topic and understanding. Okay, and relation between effective and peak value of AC. This is very most important. Okay, and this relation IEFF or IRMS 1 by root 2 I naught is equal to 0.707 I naught. Okay, and next root means square RMS or virtual or effective value of AC, and relations between average value and peak value of AC. This is very most important. I average is equal to 0.637 I naught and mean of average value of AC. This is very most important. Okay, and this is the next amplitude. It is very most important. I naught time period T is equal to 2 pi by omega. Alternating current. Okay, is equal to E naught sin omega t. Thank you. Take care. Goodbye.